Okay, the second part of solving equations that we're going to look at are solving radical equations. And you might be wondering why radicals when we just finished rationals. Reason is they both have extraneous solutions, okay? The process of solving radical equations, you square both sides. So what can happen in that process is a solution looks like it works even though it doesn't. And you might be thinking, what is she talking about, right? So if I asked you, does -5 equal +5? You're going to say, no way, right? One's negative, one's positive, not the same thing. They're opposites. But when I square a -5, I get 25. When I square a +5, I get 25. Now are they equal? Yes, right? Does that mean we can conclude that -5 equals +5? Still no. So this is why you're going to get solutions that tend to look like they work, though they don't. So we always, always, always have to check our answers to make sure that they work, okay? And going back to this reason right here, when you square both sides, you can create solutions that look like they work, but they really don't, okay? So first one we're going to look at is probably the simplest one in the group here, which is number 6, okay? Before we do the squaring of both sides, because we know that's how you get rid of radicals, right? Think about it. If you have square root of 4, if you square it, that means you're doing square root of 4 times square root of 4, which is square root of 16, which is 4. Square root of 5 squared is square root of 5 times square root of 5, which is square root of 25, which is 5. So when you square a radical, all it does, we can go right to this. It just gets rid of it, okay? So don't forget that. But to do that, you want to isolate this. You want that to be the only thing on the one side of the equation. So what we're going to do is we're going to subtract 5, and we get square root of 2x minus 1 equals -3. At this point, because we're alone, we're going to square that. You get 2x minus 1 equals 9. You solve this like a simple algebra problem, and you get x equals 5, okay? You cannot just say, okay, that's my answer, I'm good to go. You have to check it, okay? So the way we check it, plug it in. And you're going to ask yourself, does this equal a +2? So you get the square root of 10 minus 1, which is the square root of 9, which is 3. Does 3 plus 5 equal 2? Answer is no. So this does not work, and our answer is no solution. So what does that mean? It means one of a few things, a few ways you can look at it. If you were to graph this as your y1 and you were to graph this as your y2, they will never cross. That y1 will never equal a value of 2. The other thing, some of you may have noticed this. In this line right here, before you squared both sides, you had the square root of 2x minus 1 equaling a -3. You might have thought right away, it can't equal a negative. That's impossible. That's true. It is impossible. So if you recognize that you have a radical equal to a negative number, right away you can put a line through here and write no solution. But you have to show that. You can't just say no solution. If you don't recognize it, you go through the work, you check it, you see it doesn't work. Okay? Next one we're going to look at is why don't we go to question 9? So question 9, the radical is by itself, so we are ready to go. We're going to square both sides. But just remember, that means you have to square that. That does not become x squared minus 9. It becomes x minus 3 times x minus 3, which is x squared minus 3x minus 3x plus 9. You have to FOIL that. Do not forget all your rules of Algebra 1. And on the right, it eliminates. Notice you have a quadratic, so we want to set it equal to 0. That's our only way to solve this. I'm going to add 2x to both sides, and I'm going to subtract 30. And our two factors of -21 that add up to 4. And our answers, when we set those equal to 0, are 7 and -3. Do not circle your answers right away and say, oh, that's my answer. You have to check it. A few ways you can check it. 1. Plug them in. Okay, so let's check x equals 7. 7 minus 3 is 4. And 4 does equal the square root of 16, which is 4. So 7 works. If you're checking -3, when we plug it in, you get -6 equals the square root of 30 plus 6. Does -6 equal the square root of 36? Answer is no. Your only answer is 7. Okay? Another way you could check it is you could say your left side of the equation is your y1. Your right side of your equation is your y2. Graph it. See, do they cross at 7? Do they cross at -3? Okay, you're only using your graphing utility to check, not to solve, okay? So only to check, not to solve. All right. There's the worked out example one you can definitely follow. They go through the check process. There's 2 more. We will do them. We'll do 10 last because that's the toughest of them all. Here, you might be thinking, oh, this looks hard. It does because you have 2 radicals. We need to isolate them. You got to get one on one side, one on the other, if possible. And this is possible. So move the other one over, and you have 2 square root of x plus 8 equals 3 square root of x minus 2. Now, when you square both sides, you have to think about what that really means. That really means 2 times square root of x plus 8 times 2 times square root of x plus 8. Remember, multiplication can be done in any order, right? So I'm going to multiply my 2 times my 2 first. Then I'm going to multiply my radicals by each other. And then I'm going to multiply those out. So that's what you actually get when you square the left side. We do not want to have to write this out, right? Since you are squaring a product are 2 things being multiplied. Your 2 things being multiplied are 2 and square root of x plus 8. You just need to square each term. So on the right side, I'm not going to go through it that way. I'm going to say, okay, this equals 3 squared times square root of x minus 2 squared, and go right to it. Oops, not 19. 9x minus 18. No quadratic. Get your x's to one side, get your numbers to the other, and we get x equals 50 or x equals 10, sorry. Do not circle your answer yet. You have to check your work. You can check it by plugging it in. You get 2 times the square root of 10 plus 8 minus 3 times the square root of 10 minus 2. And you might be thinking, that doesn't equal 0. Yeah, right now it doesn't look like it does. But remember, square root of 18 is 9 times 2, which gives you 3 radical 2. 8 is 4 times 2, which gives you 2 radical 2. So you get 6 radical 2 minus 6 radical 2. That does equal 0. So x equals 10 does work. Okay? And remember, at any point, you guys, you can pause it. You can go back and rewatch it. That is the nice part about doing this is in the classroom, you can't sit there and pause it and have me go back and rewatch it while I'm moving on. So any of those, if you need to pause it and go rewatch it again and listen to the explanation, or watch it first, then go through and do it. Okay, this one, this is the trickiest of them all, okay? So we have 2 radicals. They are on opposite sides. That is great. You have that minus 5 there. That's a problem, okay? Technically, you can keep it there. You can move it over here as well. No matter what, when we square both sides, one of them is going to include foiling, okay, which is kind of a bummer, but it does happen. So I'm just going to leave it there because that's the way it's set up. What this means that we are doing on the left side is we are foiling this. On the right side, it's easy. Radical's gone, okay? So you do have to go through and do first times first. When you do outside times outside, you get -5 square root of x plus 7. Inside times inside, same thing. Last times last. So when I combine my like terms, I get x plus 32 minus 10 square root of x plus 7 equals 6 minus x. Now, what has happened? We have another radical right here. So it's kind of like starting the other problems all over again. We need to get it by itself. So I'm going to move everything else except that to the other side, okay? So when I do negative x minus x gives me negative 2x.
This is my phone.
Shh. When I do 6 minus 32, when I do 6 minus 32, I get negative 26, okay? Technically, before squaring both sides, we could divide by negative 10, but then you're squaring with fractions, so I would say don't do that. Let's just square right now. You are going to have to FOIL on the right. Over here, negative 10 squared is 100. So you can see here that you do have a quadratic. So we are going to want to set this equal to 0 and factor. So we have 4x squared plus 4x minus 24, right? Yes. And notice everything is divisible by 4, so that is good. So you have x squared plus x minus 6, and our two factors of negative 6 that add up to positive 1 are x plus 3, x minus 2. And you get negative 3 and 2. So what we have to do is go back and plug it in to see if either work, okay? When you plug in negative 3, you get the square root of 4 minus 5, which is 2 minus 5, which is negative 3, equal to the square root of 9. So that is, which one did I say I was checking? Negative 3. So that doesn't work because those are not equal. And then when you check, what was the other one? 2. When you plug in 2, you get 2 plus 7 is 9. 3 minus 5 is negative 2. On the other side, when you plug in 2, you get the square root of 4, which is a positive 2. So actually, which is a bummer, none of these work. So after all that, neither one of them work. And this answer would be a no solution, which is kind of sad after all that work. But the biggest point here for you to take from that problem is seeing how to square both sides when you have radicals and a number, and how to FOIL with radicals.